business. In this module, we'll look at regression diagnostics. That is, how do we know if our fitted model meets the assumptions behind linear regression? So there are 5 lessons in this module. First, visual exploration before doing regression. The second is Anscombe's quartet. The third is the assumptions behind linear models. The fourth is common problems and fixes, part 1, and then common problems and fixes in fitting linear regression, part 2. Some useful graphs to view before doing regression are univariate graphs, 2-dimensional graphs or scatter plots, 3D plots if you have the right software, and correlation matrix plots. So we're going to use the same example from the module on linear regression. This is the housing data set in the ECDAT package in R, and we've seen this example with lots of attributes for each house like price, lot size, bedrooms, and so on. So the first graph that we'll see is histograms. Here are 3 histograms, one with size 500, one with size 10,000, and one with size 50,000. So these are the different bin sizes that I've used. You can get an idea, for example, with the second histogram, if the data is normally distributed or it's skewed. But you need to be careful when you use histograms to make sure that you use the most appropriate bin size. If the variable is skewed, as these 2 examples show, if it's skewed to the right or if it's skewed to the left, you may need to use the log of the variable in your regression model. Of course, if there are 0 values present or values with 0 present, then you need to add 1 to the variable. We usually use natural logs since they're easier to interpret. Again, remember that the log of a large number is a small number, so using logs is one way to do variance reduction transformations. Another useful univariate plot is the box plot. Here we draw box plots for different number of bedrooms, prices versus different number of bedrooms. The central box is drawn between the 25th and the 75th percentile of the data. The line inside the box represents the median value, and the box plots can be used to detect skewness. For example, in the box plot for houses with 3 bedrooms, there are a lot of values which are above the 75th percentile, so it's skewed to the right. Box plots can also be used to show outlier. For example, in the box plot for 4 bedrooms, there are a lot of values for homes which are highly priced. Another useful chart is scatter plots. Scatter plots is probably the most helpful type of graph for displaying 2 variables. Sometimes it's helpful to add a function. In this case, I've used the Lewis smoothing function, or you could add a linear model or any other function just to help you understand the bivariate data better. Scatter plots with 2 discrete variables are a bit more difficult to use than this particular example. It may be helpful to do 3-dimensional plots for further visual exploration. There are several packages in R to do 3D plots. Here's an example, it's called Scatterplot 3D, and here I'm showing a linear regression which has 2 explanatory variables and 1 dependent variable. We've seen correlation matrices in the module on linear regression. It's always useful to do correlation plots of the key variables prior to building a linear regression model. This matrix also shows the PDFs of each variable along the diagonal and scatter plots of the 2 variables in the lower triangle.